Good afternoon to everybody from Athens. I welcome you to this first ever webinar we're organizing on AI and energy. This is our first attempt to approach the subject of AI, and we are very fortunate because we have assembled a first-class team of energy professionals and IT professionals who are working already many years in this field and are very familiar. Of course, AI emerged as a distinct discipline over the last few years. Although AI thinking and AI applications have been involved in all aspects of science and technology over the last few years. The breakthrough obviously came 2 years ago with the ChatGPT, where people became aware that we can actually think in an accelerated fashion. And not only that, that there are machines which can learn to think and act as we do, or even better as we do. So naturally, over the last 2 years, there has been an acceleration of interest from all sorts of areas. However, energy, we believe, is at the forefront because of the huge implications in terms of energy demand, use of AI to be able to manage a lot better and more efficiently energy systems, which have become very complex of late, and opening, of course, new avenues of exploration and work in this field. What we're going to do today is we're trying to assess how energy and AI mingle, how they amalgamate, how they can function together, the one for the other. And I think we get a very clear demonstration of the huge implications by the interest that has been accelerating again over the last few months on data centers. Suddenly we became aware that data centers require a lot of energy, but data centers at the same time are essential in AI applications and AI thinking. I will just point out the various types of AI that we are currently dealing with as a very short introduction. According to the IEA, which produced a very interesting report called Energy and AI, very recently, almost a month ago, we have the following types of AI. One is the predictive artificial intelligence, and refers to the use of AI models to predict future outcomes. And then we have the generative AI, which refers to applications that focus on generating new content, such as text, images, audio, video, etc. And of course, ChatGPT is the application which came first to encompass all this. And while generative AI can be further categorized into numerous different variants, the following 3 categories are worth noting: language models, multimodal models, large reasoning models. And of course, following that, we have computer vision, physical AI, which is the interaction with machines and AI, and agentic AI, which in broad terms encompasses autonomous agents designed to execute specific tasks. I will not say more. I just want to add that IEA, which had expressed interest to participate in today's seminar, for time restrictions, they cannot do that, but they have very kindly offered to host a special webinar in cooperation with our institute over the next few weeks, where they're going to make a presentation of this very interesting study. So you will hear from us on this issue in the next few days, over the next few days, once we have fixed the day and time. And that will be a presentation made by the IEA people who were involved in the study, and will be few of us who are going to comment and ask questions. So I will say no more, but go straight to our first speaker, my dear friend and professor of electrical and computer engineering at the National Technical University of Athens, Professor Vasilis Veskoukis. Vasilis, you have the floor.
Thank you very much, Kostis. It's an honor and a pleasure to be with you today. I have just pressed the share button. I trust that you can see my screen.
Yes, very clearly.
Okay. So I will be discussing principles of AI and use in energy applications. And I will try to balance between some theoretical and classification of AI-related technologies and I will try to present some real-world applications. Everybody is talking about AI recently, and if there's a second thing that everybody is also talking about, this is energy transition. And the thing is that AI definitely relates to energy transition. It has a lot to offer. It definitely has to be involved. These technologies must be involved one way or another with energy transition. How exactly, to what extent, under which terms, and what we need to do remains to be determined. But before going any further, I would like to add as a keyword the word hype, which is also noted in red. I mean, we have a lot of really useful stuff, but we also have hype, which needs to be noted. So what I have tried to accomplish with this slide is present some sort of a rough map of AI-related technologies. And some of them are not new at all. We have been discussing about expert systems for decades. We have been talking about knowledge-based systems, knowledge representation, and all that kind of stuff, like from the 60s or somewhere close. So yes, there have been traces of AI applications that go way back. But the thing is that recent technology developments have allowed a new family of technologies to flourish. And now we have all these neural networks, deep learning, and machine learning technologies that go and are further divided into many categories. And you have a lot of keywords to talk about, like generative adversarial networks and stuff like that. Most importantly, the common denominator of all these is data. AI is based on data, as is every other technology that we have been dealing with during the past decades. But what is different, the game changer here is the amount of data and how easy it is to collect and data from any kind of activities that without effort as it used to be in the past. And on the lower side part of the slide, you can see a few applications, few families of applications. We are familiar with most of them. I will not try to go through and read the titles, but what I would like to kind of emphasize is that most of them, if not all of them, can be related to energy. And probably everything that regards technologies of AI is related to energy, and many applications, including computer vision applications, can be developed using AI technologies. And this is indeed a game changer because, as I said before, we have a huge amounts of data, all kinds of data, not only text-based data. We also have media that we collect in real time, and there is sky's the limit, as we say, into imagining what sort of applications can be developed using AI in energy. So the next step into structuring this introductory effort is to classify a couple of applications and relate these applications to AI technologies. So I would propose a classification of three main categories. One has to do with forecasting, because this has already mentioned that. One has to do with optimization, and needless to say, energy people have a lot of optimization and forecasting to do. And maybe a new one has to do with classification, which is about understanding and classifying behaviors, activities, data, and everything observable and even remotely connected to energy. So I will try to focus on these three categories a little bit more. And well known, I'm not going to take longer here, that we all need to forecast everything that is related to energy quantity. Load generation, weather is also related to both to load and generation. Of course, price, consumption, and everything else that you can see through this slide. And the new kid in town, to put it this way, is the vehicle charging, is electric vehicles, which is a totally new category of consumption, which depending on how big the penetration of the electric vehicles will be, is definitely going to change the landscape. And energy has to use every possible tool to follow and stand up to the requirements and expectations. Another very familiar area of application is in energy is optimization, and optimization has several aspects, several facets, several viewpoints, how to put it, depending on the stakeholder being heading the problem of the optimization. So we have energy management at the operators level, but also at the consumers level. And we have trading risk management for market participants. We have bidding optimization, storage management, and storage, as we all know, is going to be evolving hugely during the next years to come. We have energy communities. We have vehicles here as well. We have automatic control, environment-related stuff, and last but not least, disaster recovery and resilience that do not only relate to energy systems, production, distribution, and transmission, but also to infrastructures and everything. I forgot to mention that in these slides, I have tried also to display a few traditional technologies that relate to the field. And now, definitely with application relating to forecasting, to optimization, we have linear programming, we have mixed integer programming, and technologies like that. And last but not least, we have a new family of application relating to classification, meaning to understand the behavior of consumers, of communities, or to classify events, faults, and stuff like that in the scale of individuals, starting from individuals and scaling up to buildings, to cities, to areas, communities, or segments of the economy, or whatever. We had some tools to do something like this before, like rule-based systems and statistical methods, but now we definitely have more tools. I have also attempted to make an arbitrary definitely a matrix of relating AI and traditional technologies to the applications that I have mentioned. And if I may zoom a little bit more, in the forecastings we have this mapping, and regarding optimization, definitely you can see without digging into details that all modern AI technologies are involved in most of these areas of application. But we also have traditional technologies that remain and are complementary and at the basis, and in some cases they are not ready to we're not ready to say goodbye to these to tools based on these applications. Okay, so I will try to present briefly four examples of applications of AI in energy systems. The first one is about hybrid storage management, which is about optimizing storage of energy in both in batteries and in hydrogen. And you need to know how much energy from renewable sources you have, and what is expected is the price going to be. So we have price assessments or forecasting as well, and you apply different methods in order to take energy management decisions, either to store in battery or hydrogen, or to sell energy or hydrogen, and at which price, and so on. So we're talking about an application that is about both forecasting and optimization. A second case is about data infrastructures, and admittedly, data is a very important element of energy systems. In the past, we had some what I call here legacy energy data infrastructures, where all you do is collect data from as many sources as possible and make it available to the organization involved in whatever operation in energy. But with AI, you can do a lot more. You can add semantics, you can imply georeferences, you can combine all these things, you can bring in ontologies, vocabularies about practically everything. You can even bring in data that is not structured or is not per se measurements, but it is data coming from news feeds, online postings, and knowledge in general available out there. And you can combine all of these and have except for the traditional energy infrastructure, you also have AI, custom AI based access to the data. Another application is about understanding energy time series using semantics and using AI models to optimize and classify the data that comes in time series. And this is very, very, very important, I may say, because on the top diagram on the right hand side of the slide, you see the same time series, but the diagram, the small diagram, has not been processed using knowledge about what this time series actually is, and it gives the impression that some quantity is getting higher and higher values by time, which is not exactly the case. So you can do a lot of things in here. You can do customer profiling, you can do business intelligence in time series, and if you are on the regulatory side, you can support a decision and develop policies. And last, I'm trying to keep my time as possible. There's this application about intelligent energy communities, and actually I'm mentioning this again because this brings together all families of application classifications, both forecasting, optimization, and classification. And this is about developing energy communities from domestic individuals that share physical storage, physical domestic rest production, and also virtual rest production from curtailments. And the idea is that if you put them all together, you need to do a lot of stuff like load forecasting at the home level and at the community level, and you need to do a lot of optimization so as to share infrastructures, to share the storage for the storage that is available, and everything that can be shared in a community so as to minimize the cost and the benefit for the participants. And also you have,
Εξαφανιστεί ένα βίντεο από αυτό που είμαι εγώ. Μπορείς να το βοηθήσεις?
excuse me, can you hear me? Okay. And another aspect is that you need to understand the behavior of consumers. And this is something that is going to be really popular in the future. You need to infer using non-intrusive methods, if available, what each individual consumer does so as to be able to offer competitive products, to be able to understand the load it produces and how this load is distributed over time, and perhaps even give incentives to change the behaviors consumers so as to optimize some other quantity in the energy system. I'm not going to spend more time here. I can spend as much time as you might need. But one important thing that I want to emphasize is that traditional methods are not dead. I mean, there are many applications, and in the last case, I have already mentioned some of them, that you need to apply signal processing, for example, before applying AI technologies in order to do whatever it is that you're trying to do. But for example, you need to collect data, you need to filter data, sanitize, and do some statistical processing that is perfectly well done with signal processing, and then you take out the feature vector and you do whatever you'd want to do with AI technologies. And this is to just to bring me to my concluding slide. I would like to point out a few things as material for the discussion afterwards. The first is that AI is not a panacea. It's very popular, I understand, and there's a lot of hype that is fed by both marketing and politics. But the thing is that there are a lot of things that need to be dealt with. For example, we need to understand how to charge and how to pay for whatever AI related. We need to deal with liability, quality, and most importantly, ethics of AI. We need to understand how to evaluate AI systems. Okay, they're new, but being new doesn't make you any better. You need to prove yourself, and this goes with people, this goes with technologies, and you need, especially in critical infrastructure applications such as energy, you need quantitative and provable assessment that, okay, doing this with AI provides a measurable improvement. And also another very important point is whatever we have been using so far, we will be using in the future as well. We will be using signal processing, we will be using optimization, and if we have models that already do the job, we need to build on top of them, probably to build applications that improve or combine these services with AI based services so as to produce more efficient and more advanced results. And I'm taking the diagram from IEA 2025 report to point out that AI goes very well with visual understanding, with possibly with coding and everything, but scientific understanding still is not where it needs to be so as to trust AI for like anything. And my last point is that no matter what, no matter how mature AI technologies will be, and especially for domain applications like in the energy, we need data of high quality. And this is not going to change either to train AI or to apply AI models in decision support, forecasting, classification, anything, we need data of high quality, and this is not going to change. So thank you. I think I put a full stop here, and I'm happy, more than happy to discuss with you.
Okay, Vasilis, thank you very much. I could not have wished for a better introduction into this webinar.
Thank you.
I think you covered in very short time the whole range, and a very good introduction in the sense of differentiating, as you rightly pointed out at the start, the hype from the actual situation. And your last observation about the quality of data finds me very supportive, in the sense that from the little use I'm making of AI, I have noticed myself that it's the correct information that you will feed in that makes all the difference. If the information you feed in suffers quantitatively or qualitatively, then obviously the result that will come out is, shows this. It's very clear. So yes, quality of, but of course, AI, as you know, and all people who are involved know, that make us very complacent that everything works perfectly. Therefore, the attention on high quality data is, I think, very essential. So I will ask if there are any questions on the issues and the information that Vasilis Veskoukis has brought to us. We have time for 2 or 3 short questions with short answers before we move to our next speaker. I see one chat here saying, what? No, it's just a general information from the providers. I cannot see any other hands. So we move to our next speaker, and we get questions and answers at the end. So we now move to the IT part of the equation of energy and AI, more on the AI part and the IT background. And I shall call Dr. Alexandros Papaspiridis, who is General Manager of Nephos Consulting based at UAE. So, Alexandros, here you are, and you have the floor.
Thank you, Kosti, and it was great for this webinar. I think you're breaking new ground, and I would like to thank you for the invitation for this, and I'm looking forward to the next. Vasilis gave us a very interesting presentation, and I would like to bring not just the IT, the technology perspective and how the technology connects to the business. So let me share my screen with my presentation. Okay, perfect. Kosti, you mentioned the IEA report, which it's a very interesting report. It's 300 pages, is very, very long, but it has some very interesting snippets. And one of them is where I would like to start, is that AI is called as a general purpose technology. And IEA used the same expression as Sundar Pichai of Google, that is very much like electricity, that is shaping the new industrial revolution. And we would like to remind us that this has been a sequence of big steps that all have been able to capitalize on the previous ones. So we had the electricity, the semiconductors in the 50s, the personal computer era that democratized access to computing, internet that has become pervasive. And now AI is building on all these general purpose technologies before it, and has allowed the very quick, very fast, it's only 2.5 years old, the generative AI component, but AI technology that started like 50 years ago I think we have managed to spread very, very quickly because we have been able to build on these shoulders of giants that have been the predecessors. So the impact, as you said very eloquently, Kostis, has been tremendous. And now we are looking at the data center electricity use, which is projected to have doubled over just 3 years ago to more than 1,000 terawatt. And what does this mean? It means that it's already the cloud and AI infrastructure that we have in place will consume as much as electricity as Japan, one of the G7 economies. And this is the picture until today. Where it goes is we have to look a little bit about how the progress of the technology of the data centers. And, the top clusters like the XAI Colossus is requiring today at about 150 to 250 megawatt. But look at what announcements have been made last week about 2 mega factories. One in UAE, which is now going to consume 5 gigawatts of power, and another one which will be built in Paris at 1.4. We are looking already at a factor of 10 to 30 times bigger than the state of the art. So this shows the increase in computational demand that we have throughout the world, but also shows the strain that we will be imposing this rapid growth on the demands on electricity. So that's one facet. But the other facet as well is that now it's driving the energy transition. So the hyperscalers, this is the term that is being used for the likes of Microsoft Azure and AWS and Google Cloud. The hyperscalers are driving also renewable energy growth. So because the hyperscalers have pledged, they have committed to go zero carbon. So therefore, renewables is a big part of how we will be able to keep this pledge for the data centers growth. So this is now driving a huge portfolio of green energy, which is about 10 to 20 gigawatts per each of the big hyperscalers. It's also driving nuclear, whether it's the 3 Mile Island that is now going to restart and will be connected to Microsoft data centers, or whether the progress and the investments that are happening on small modular reactors, or the fact that even oil-rich and gas-rich countries like the UAE are having nuclear as part of the mix to be able to offer a sustainable future of the data centers. And the third is that the long-term PPAs is an opportunity to finance these green deployments that we need. So AI is having tangible business impact, and this tangible business impact that they are having is really spectacular. I've looked at 4 examples, 3 international, 1 in Greece, about what AI can do. So Ørsted, they are managing to increase the wind farm output by 5%, which is pretty significant. National Grid is saving $300 million annually, and Microsoft is reducing the cooling energy by 40%. Mm-hmm. And even in Greece, Metlen is now is using AI to do energy price forecasting for 12 markets with 31 days ahead. So AI is already driving this tangible business impact. We did at Nefos Consulting, we did an analysis of how AI is used in energy companies, and we are producing a white paper on that. But I would like to focus on here about what's the low-hanging fruit. What are the things that one energy company can start looking? And we've looked at 3 use cases as this low-hanging fruit, which represent a high business impact at the same time with moderate and low complexity. And these are the predictive maintenance for the critical assets. It is how we do customer segmentation and customer usage analytics. And the third has to do with ESG analytics and the carbon footprint reporting. So these are use cases that a company can start focusing and to drive impact in the beginning, because AI is not like traditional IT projects. It's a transformation technology. It's not an IT technology, it's a transformative technology, and it can drive impact in a short time frame. So us at Nephos Consulting, our theme is about how AI can be a technology, a transformative technology, but at the same time, it's a simple technology and a pervasive technology, as the same way that Excel is a technology that is being used for everyone. You don't have to be an expert to be able to use Excel and have the benefits. So that it's a transformative technology, but at the same time, a technology that can be very simple. So the way we are doing it is we are focusing on 3 clear steps, which we are helping a company to realize benefit in a very short time frame. We're starting from a masterclass, which is a half-day workshop that we allow organizations to understand 360 what is AI and what are the implications. And my predecessor mentioned about ethics and also some of the limitations of the technology. So you have to understand this, you have to have a 360 view. The second one is to be able to use AI as your personal assistant. There's nothing really that I do on my day-to-day that doesn't go through AI, because my AI is my mental partner that allows me to go back and forth and improve the output of the work that I'm doing. And we have a 12-week series of sprints, which we are allowed to a team to be able to use AI as a personal assistant. And the third is, when we're looking at an organization, whether it's a division or the whole of the company, is we're going through a process of business value design thinking to be able to allow to look about what are the use cases that have to be prioritized. And every company has its own strategy, and therefore the AI use cases differ. You cannot, it's not like going to a supermarket and select, okay, I want these use cases and that, the other use cases, but you have really to build through the design thinking process to be able to derive what are the use cases that are aligned to your strategy and drive this business impact. So these 3 steps allow to take you through this ladder, and you can see that these 3 steps can happen over a number of weeks. So Kostis asked me to be able to be very succinct and to leave time at that. So I would like to wrap my presentation and say, this is the time for you. It's not next year, it's now. Greece is already lagging from the European and global adoption of AI. And I think because there's a lot of fear about that this is a complex technology that is not relevant for us. I would like to leave you with the exact opposite message. AI is a technology which is transformative, but also can be very simple. Thank you.
Okay, thank you, Alexandros, for really concise and yet very inspiring presentation. I think you have brought to the fore the issues at hand, especially as regarding users like ourselves, that we are trying now to find our way to use AI. And I can tell you that we have started in this using AI for various applications, very slowly. But I can tell you that the rate is increasing day by day. So what you said makes a lot of sense. One observation I have to make, though, is that in UAE, very rightly and very well ahead of time, you predicted the high rise in terms of electricity use, and therefore you are now supported by nuclear power, which you mentioned is key. And I agree with you that it is key. I have my reservations concerning renewables. Not that I'm against renewables, but they will not be able to catch up and provide all the necessary energy that is going to be required. Therefore, models which were made even 2-3 years ago have to be scrapped and include in them various assumptions about much faster increase of electricity use, which obviously cannot be served only by renewables. Therefore, nuclear, which you demonstrated very aptly, is part of the answer. I would say natural gas also. So we're not going to be able just to glide through energy transition. Energy transition is not going to happen so likely because demand will keep on increasing unpredictably. And I think we agree on the unpredictability of demand. So I will say no more. I will ask if there are any quick questions now before we move to our next speaker and group all the questions at the end. Okay, I see no hands. So thank you once again. And we move immediately to our next speaker, which is Dr. Dimitra Apostolopoulou. And she is a research fellow from the Oxford Institute of Energy Studies, with whom we have a very good association and contact for many years. And I'd like, before giving the floor to Dimitra, to point out that the Institute, the Oxford Institute, brought up a very topical report on artificial intelligence and its implications for electricity systems, which is contained in the monthly forum report which they produce, and which Dimitra had she was in charge of all the editing and compilation of the reports. So I'll say no more, but give the floor to Dimitra.
Thanks, Kostei, and many thanks for having me here and for the nice introduction. And so let me share can you see my screen?
We'll see it in a minute.
Sorry. Give me a few seconds. There. Now you will be able to see my screen.
Right. Okay.
Okay. So again, many thanks for the introduction and for having me here. So today I'm going to talk about the complex relationship between AI growth, data centers, and energy transition. I think the previous two speakers gave a nice overview, Vasilis, of the type of AI applications we have in power systems, and Alexandros of how we can use AI and how we can power AI and the direct impact we're going to have on electricity systems. So as Kostis said, we're from the OIS, so the Oxford Institute for Energy Studies. We're an independent research institute based in Oxford. And we have 7 programs. That is the oil, the gas, the electricity, China, hydrogen, carbon management, and the overarching energy transition. I'm part of the electricity research program, and our research spans across 3 main themes. That is how you can design markets for the net zero systems, how you can better utilize the networks, and how you can incentivize consumers. So we recently published the Oxford Energy Forum, which is a quarterly journal, and it was about AI and its implication for electricity systems. So my talk today is going to give you the key highlights of this forum, as well as a deeper dive on some of the research we have done at the Institute. To give you a teaser of the presentation, we're first going to cover how AI applications can transform energy systems and how they can undeniably be beneficial for decreasing the CO2 emissions and helping the energy transition if you apply it to power system operations. How though electricity demand is going to increase, and one of the reasons is data centers. What we can do to mitigate that. And last, I'm going to finish with the indirect impacts of AI, which are usually not being accounted for. So similarly, Vasilis, I don't know, a similar kind of categorization that you did, I found from a paper. First, to define an AI application, we have to find the supply chain element. So that is one of these column vectors. Then we use the use case, how we can, what's the purpose, why we're using AI, and what sort of AI we're using. So, people have calculated different numbers of how this can help power system operations and the cost, the reduction in the cost. What I'll talk about, based on some research we have done, is how, by choosing distribution systems, we can automate the grid by using learning approaches. Okay, so the goal is to transform data into actions. So historically, we had large power systems that were meeting the load, and we had this kind of one-directional flow from the large plants to the load centers. Now we have all these smaller producers, the distributed generation, that we want to include in our system. We want to leverage them for the system benefits. And before, we couldn't do that because we did have observability issues, we're caring about reliability. But now we know what's happening in our system better because we have our advanced metering infrastructures. We have access to real-time data, which gives us an idea of what's happening in the system. So previously, we used to control the smaller producers by using some sort of predefined model that we thought the system was looking like, and then sending control signals to the distributed energy sources. Now, and you can find more details in our paper in the forum, we are suggesting to use real-time operational data to actually learn the network model. That's going to represent the actual system condition. And then you feed that, as you can see here in the graph, into your control system, and then you give DR, this is distributed energy resources, dispatch actions that are actually going to help your system. In the past, there was a recent blackout everyone is talking about, but we have been having blackouts in history, and some of them are due to having a bad model, so then operators make bad decisions that could lead to a system collapse. And I just talked about one application as one part of our research. Vasilis mentioned a lot also. So imagine if we merge all these AI applications into our control systems and in our control room. And this is a picture I found from NREL, which I found very futuristic. And the future control room is going to look a lot different than today's control room. And not only by using all of these automated sort of approaches by leveraging AI and increasing the system efficiency, reliability, sustainability, but also helping operators. You can use LLMs to get all the alerts in the system and then, process the data and then bring to the operators the most important ones. So there are many ways that AI can help power system operations, and there are many classifications and taxonomies of how we can do that. Okay, so AI is applied to power systems, AI is applied to many industries as well. And I'm sure Kostis mentioned you have used it, I have used ChatGPT. I'm not also a very high tech person, but I think and imagine younger generations. I know some of my students, they ask, they have a Python exercise and they say, please write me a code for how to perform linear regression. So we can imagine how many people are using AI nowadays. And this is driving the electricity demand. So here is a graph of, okay, we know it's going to go up. We don't know how much. And as you can see in the left-hand side, electricity demand is going to increase for other reasons. We have electrification of transport, we have electric vehicles, electrification of heat, green hydrogen, but data center hold a very big portion, okay? And Alexandros mentioned, you have all this development of data centers in different countries. There is actually a geopolitical arms race to develop AI, and that's driving AI demand a lot. And we have a lot of data nowadays. So the volume of data is also driving AI demand. On the bright side, there are also factors that make the demand to have a decreasing trend. That is, we have hardware advancements, we have algorithmic optimization, and we have open source models, meaning that we don't have to train from scratch. So my point is just the takeaway message here is that AI demand, the direct impact of AI on electricity system is that it's going to increase the energy consumption. We don't know though how much and where. Okay, there's a lot of uncertainty in that. So what can we do to mitigate the direct impact of data centers? We can go to economies of scale, we can go to policy and market incentives, energy management systems, infrastructure efficiency. I'm going to talk about, because this is the point you made, of can renewables power data centers? I agree with your point, given the capacity of renewables and if the demand, we're going to have resource adequacy issues. We need to build more renewables besides data center. I mean, demand is growing. We need to build more capacity. But I think coupling the data centers with renewables and treating them having some flexible demand is doable. There have been some effort in that direction that instead of having data centers that are on 100% reliability, constant power, they do have some flexibility of making their operations so that they can respond to grid signals. However, there are no grid signals. There is no incentive for data centers, monetary incentives for them to change their demand based on the needs of the grid. But that's something that could change, with proper electricity market design, with regulations. The EU has made that data centers need to be energy efficient if they're larger than 1 megawatt. So there are ways around that. I'm going to focus on the last point, which is how we can increase the efficiency within the data centers and how we can use the heat that is being generated from data centers. So again, I'll point you to one of our papers in the forum. So heat is a byproduct of data centers. They use nearly they turn all their electricity into heat, and because they're very energy intensive, they can supply kind of continuous and insufficient amount heat. So instead of just wasting this heat or leave it unutilized and just dissipating the environment, contributing thermal pollution, we could have some waste heat recovery projects, and we do have some across big data centers. The ones that have been successful have been in places where there was district heating infrastructure and there were clear policies for heat recovery. And why is that? So here in the graph, you can see the various heat applications, the waste heat recovery applications. So either you use it for in-house, either you use it for generation, or you use it for your neighbors, or if you have a district neighbor, for your district heat network. So in places like Denmark, where there is already some district heating, it's easier for data centers to have some waste heat recovery methods. However, even there, you need to have the appropriate holistic sort of support in terms of economic incentives, regulatory support, because the data center might not want to become a kind of expert in heat. So there needs to be a way that this is a win-win situation for both the data center as well as the end consumers in a simple way. So in order to have a success in how you turn in waste heat recovery projects, we need to have this holistic approach. And that brings me to the last part of the talk. So we covered how you can use AI in power systems, the impact it has on electricity by increasing demand, what we can do to mitigate this increase. But now let's also define the indirect impacts, which are those from energy consumed or saved by AI applications. So this is something that not a lot of people talk about. So we have the power systems, and the three of us have already talked about that. and why AI applications are beneficial. That's unambiguously, everyone agrees that. And then you have other applications, let's say, that for the energy transition, they have a negative, they hinder it as, if they help the efficiency in oil extraction or something. So that's also, let's say, that is a detrimental effect on the energy transition. But then you have all these other applications that could either be on the positive side or the negative side. So you see all these applications can either have a positive effect or a negative effect on the energy transition. So an example is fashion. Okay, so in fashion we have Vinted. I don't know if you have used it, where I have something I'm not wearing anymore. I sell it, so you kind of recycle clothing. That's good for the energy transition. And then you have sale, which is very cheap, very fast, big quantities, sort of very big carbon footprint. AI enables both sort of paradigms. Another example is autonomous vehicles. So in autonomous vehicles, we can see a decrease in the energy demand because you have optimized routing, you have less driving, you have more people in the same car, you're sharing, or you can have an increase. Why? Because people are not going to take the train now, they're going to each take their car, or you're going to go further away. The problem with the indirect impact is that these are not mitigated by AI governors, so they're not addressed there. And they're left to individual policies relying on the individual applications. However, then it's harder to quantify what the AI indirect impact is. So that is something missing from current AI governance. And one of the authors, that Charlie Wilson, University of Oxford, analyzes this in his article in the forum. So you can see the reference there. So to sum up, some key takeaway messages are that AI is very good for power system operations. It leverages renewable resources, and it helps going towards sustainable, cost-efficient, resilient, and reliable power system. We need to incentivize flexibility from data centers, so then they are smoothly integrated into electricity systems that have a lot of renewable resources, as we hope in the next, by 2030 and by 2050, that's how our power systems will look like. If we're trying to increase the efficiency of data centers, we need to look across sectors, which is true in general in the energy transition. So we need to study holistically the heat sector with the electricity sector, even in the data center case. And last is that the indirect impacts of AI of all applications should not be neglected, and they should be measured and regulated. Thank you for your time and attention. Happy to take any questions.
Thank you very much, Dimitra, for a wonderful presentation. I agree with you on the holistic approach, because this is the only way we can navigate through this complex situation. And also your very interesting remark about the past and now. And you said in the past, we were getting information post-ante on operation of the electricity system. Now we can get it real time. And this makes a lot of difference. And I don't think we have been able so far to understand this. In his presentation, Alex Papaspiridis mentioned about Metlin using AI to predict 30 days ahead, obviously using data on a real-time basis. So we can see this happening. The question of renewables is not only my concern, but I see a question here from Dr. Christos Kolovos saying, building more renewables to serve AI growth is going to crash with social license to operate. How much land needs to be occupied for area growth? Question mark. What about local societies' approval and social unrest? Would you like to comment on that?
Thank you. So besides the AI need, if we look at the future energy scenarios, because we want to decrease emissions, we're trying to electrify different sectors. So the electricity, the transport, the heat. Okay, so demand is going to grow. Having said that, we need to both look at increasing our capacity, so building new renewables, investing in flexibility resources. So before we had the gas units. So the gas units were the flexibility in the system. That is on the generation side. Okay, we're going to be still using gas for many years, but we need to move the flexibility from the generation side to the demand side. So we need also to invest in demand side flexibility. Okay, so I agree with you. There are problems with renewable resources in terms of permitting and building new resources, and social acceptability of renewable resources has declined lately, which is a factor of having a more interconnected system, sort of why having in my land, not in my backyard, and helping the other person, my neighbor. So this can be addressed by informing people of the benefits of having renewable in the system, and obviously having, again, an environmental sort of there are many places we can build renewables that balance all the benefits and disadvantages of people involved, and that you need to have all the stakeholders, that is communities too, being involved in discussions.
We also have another question from Mirto Dimitriou saying the replacement of the old traditional systems, which are already very energy consuming, by the new AI systems will not bring a balance in the energy consumption in the future. So the energy demand will be almost equal, question mark.
So again, there are two things. We are modernizing our grid. Okay, we are doing that. Why? Because technologies are cheaper and we can do it, and it helps us. Why? Because we can have more renewables in the system. When you have more renewables in the system, you need to monitor what's going on, have a better observability of what's going on, and we have been investing on that. And I see it kind of a one-way road. We have to do that. We are also modernizing equipment in houses, if that's what the question means. Like we're going from traditional heat pumps to electric heat pumps. Even here in Oxford, there is Oxford City Council has a project that gives money for people to upgrade for free, and there is also some skepticism that why would I want to do that? Will I pay more, or what will happen? So whenever you have a change, I think there's a lot of reluctancy at start for people to accommodate. I don't think so. Using AI and applications in the power systems does help. Not maybe it is more efficient. Things are more efficient, and it helps balancing supply and demand. However, we discussed that due to the data centers and AI, energy will grow, but that's not a problem of applying AI to power systems. It's a problem of using AI in general in our lives, which again, I think is a one-way street. We are using AI in our lives. It's one of us.
Okay. One remark from me. I agree very much with your observation that right now there's a lot of uncertainty as far as energy demand prediction coming from the extensive use of data centers. There are, if you look at IEA scenarios or EU scenarios and everything, they have already started using they're factoring in the AI use. But I think the way things go, these are underrated. What do you think?
So a lot of people think, if you see graphs of projections by different organizations, the span is, you cannot imagine the slope. So so I think that we cannot have the very, very high scenario because the system is going to crash. We don't have a lot of generation. You need, in order to meet the demand, you need to have the existing generation in the system, and there is some discrepancy between building transmission interconnections, generation, and building data centers. So that's another thing. Maybe we should do a more holistic planning on all of this together. But I do think, we woke up all one day, and then when was it in February, that, in China, they have the deep secret, I think it's called. They knew faster, better. So you don't know what's going to happen. I really believe in innovation. innovation in technology. So I cannot tell you why, but I think the demand is going to plateau at some point. Like some innovation is going to come, which I mean, I'm not an IT expert, that's going to help us as it happened with, with the computing like some years ago.
Right. Okay. Very, 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 very interesting point. So thank you once again, and we move to our next speaker.
Thank you very much.
Thank you. Who is Professor George Atsalakis. He's an associate professor, head of the Laboratory of Data Analysis and Forecasting at the Technical University of Crete. So now we move south, okay? So George Atsalakis, you have the floor.
Hello to everybody. Thank you very much for the invitation. It's my honor to participate in this webinar. After hear so many important things about AI from the previous speakers, there are not too many things to say. So I'm starting the expectation that the impact of various disruptions, including geopolitical tensions, climate change effects, technological breakthroughs, and vulnerabilities in supply chains will significantly increase over the next 10 to 10 years, highlights a crucial trend in energy strategy management. States and business are increasingly recognizing the need to prepare for uncertainty as an integral part of their operational planning. The exponential growth of new technologies suggests a broad consensus on the inevitability of these challenges and the substantial impact they could have on global business operations. This expectation is driving companies to adopt more robust and flexible strategies to mitigate risks. Furthermore, the focus on preparation reflects a shift toward a more proactive approach in business strategy instead of reacting to disruption as they occur. Decision makers must proactively integrate risk management in their core business models. This includes scenario planning, stress testing, and continuous monitoring of global trends to anticipate and mitigate potential impacts before they materialize. A new global challenge is the role of the artificial intelligence in the energy sector. The previous speaker mentioned about the waves of AI. In the past, we have the artificial intelligence that was a perceptual AI. The second wave is the generative AI. The third wave is the reasoning AI that is going to solve the problems. And the next phase of AI will be the physical AI. And this where the world's major industries will benefit. Artificial intelligence will understand things like the laws of physics, friction, inertia, cause and effect. The idea that if you tickle something, it will fall. The relations between artificial intelligence and energy is bidirectional. Just as energy contributes to artificial intelligence also contributes to energy. Let's see first the contribution of energy to artificial intelligence. Artificial intelligence is a unique because it will not only drive evolution its own domain, but will also significantly impact other sectors, including the economy, politics, and even warfare. Dominance in artificial intelligence requires enormous computational power, sufficient energy supply to power the vast data centers that support AI, and finally, the human resources needed to develop new and innovative algorithms. The growing impact of artificial intelligence on energy consumption is a critical factor that must be taken into account. The sharply rising demand for energy driven by new technologies such as AI will lead to an increasingly energy-intensive landscape. As the adoption and expansion of the technological innovations continues to grow, energy consumption will escalate. The AI boom has caught the utility industry off guard, We are all aware of the exponential spread of new technologies, yet we have not adequately accounted for the speed at which energy demand is increasing due to these new technologies. For example, a single ChatGPT query requires 17 times more energy than a typical Google search. If a simple ChatGPT interaction demands 17 times more energy, just imagine the massive energy requirements when AI is deployed on a large scale. This could significantly slow down AI adoption due to two main reasons. First, the lack of infrastructure for distributing additional electricity, and second, the high cost of electricity itself. We all know that when demand rises and there is insufficient supply at the moment of consumption, prices increase. The rapid rise in AI-driven energy demand has already forced technology companies to turn to nuclear power plants to sustain artificial intelligence. Second, let's see the contribution of artificial intelligence to energy. The transition to green energy is unlikely any previous energy transition. Past energy transitions were additive. One source was introduced alongside another. Oil was discovered in 1859, overtaking coal as the world's primary energy source in becoming the dominant fuel by 1960s, nearly 100 years later. However, today's energy transition will not be driven by price as in previous transitions. Instead, it will be driven by politics and technology. Artificial intelligence and nuclear fusion. We already have a gigantic nuclear fusion reactor of the sun, which appears every day. The sun converts approximately 4 million tons of mass into energy per second. It requires no maintenance, no refueling, no planning, and no management cost. Yet it continuously generates energy. If we cannot fully harness solar energy through technological innovations, we will have to build nuclear fusion reactors on Earth to generate energy. Artificial intelligence can accelerate the research and development of nuclear fusion in two key ways: enhancing solar energy capture and storage in cost-effective battery systems, and advancing the development of nuclear fusion reactors on Earth. In other words, AI has the power to transform global geopolitics. Historically, geopolitical power has been determined by control over land, air, and sea and space. Traditionally, geopolitical power has been exercised through economic, political, and military means. Ensuring that AI accelerates nuclear fusion development will reshape the global power balance. And this is because fusion energy will be clean, cheap, and abundant. Countries that lead in AI-driven fusion energy will gain immense strategic advantages. The rise of faster, better, and more capable AI models will drive this transformation and revolutionize the energy sector. It is so coincidence that governments are competing not only for raw materials needed to power artificial intelligence, but also for the human talent required to develop and operate AI systems. It remains unclear whether AI will continue to be a race between the USA and China. For most nations, the cost of energy into AI dominance will be prohibitively high, leading to a widening gap between those who have and those who have not, and in AI capabilities. European nations are now struggling to catch up. The UK and France are attempting to invest in their own domestic AI capabilities to avoid falling behind. At the same time, citizens worldwide demand cheap and abundant energy to sustain innovation and improve their quality of life. As a conclusion, AI and energy will reshape the world. The intersection of artificial intelligence and energy represents one of the most significant challenges and opportunities of the coming decades. AI will drive energy demand to unprecedented levels, and AI will also be the key to solving the energy crisis through innovations in nuclear fusion and renewables. The nations that lead in AI and energy development will shape the global power structure of the future.
Okay, thank you very much, Professor Atsalakis. I'm marking one or two things you mentioned. First of all, that energy transition is unlike the current energy transition is unlike other energy transitions. That the energy transition of today is not driven by price, but more by technology needs, which we see very clearly in AI. And very interesting observation was the one about nuclear fusion, which obviously AI has a lot to do with this in helping us accelerate research into nuclear fusion, which could provide ample energy. And this could balance the gap, which a number of speakers mentioned earlier, between the demand and supply. And finally, you also reiterated what other also speakers said, therefore confirming that it's very hard to predict the energy demand. Okay, yes. And this is an issue which I think is going to occupy a lot of our attention over the next few months and years, because we shall have to model energy systems from a different perspective, from a different way. And yourselves being very fully involved in modeling, perhaps you could comment on this, on how do you see the demand unpredictability affecting the modeling work? Could you say a few things on that, please?
It's very difficult to make forecast for the future demand because the AI technology is going to create new factories, new AI factories. These AI factories will have huge need of energy. We speak about megawatts. Maybe traditional factories, they need 1 megawatt energy. The AI factories, they will need 6, 7, 8 times more. So we don't know yet how many users worldwide is going to use these platforms to search. And we see that is very high, the energy that is needed, even for a simple search. So imagine that when the factories will make digital twins and will simulate the real environment before any construction of future factories and whatever, all these need huge quantities of demand, and there is the possibility, the lack of supply of energy, to delay the development of AI in some places. Because AI needs supply of energy 24 hours per day and cannot be interrupted supply from renewable sources. So it's a very big challenge that sure it's going to be an interesting topic for research the next years.
Okay, Professor Atsalakis, thank you very much for your insight and your valuable contribution. And now we move further south to Israel. And I would like to invite Nadav Mantel, who is a research associate at Reichman University, I think in Tel Aviv?
Yes.
Yes, all right. So, Nadav, you have the floor.
Thank you so much. Thank you for organizing all this. It's been a really, really insightful webinar. And the speakers here have a lot of knowledge about AI. I also want to talk a little about my background as well. Apart from being a research associate at Lachlan University, actually my day job is working as an associate at the venture firm Our Crowd, where I do energy and climate. So the following talk is going to be a bit of both. So it's going to be a little bit of VC work and where we see the industry, where the money is going, what are the challenges in our view, the VC community, I'll say, and then where does that intersect with research, where it usually doesn't. Research doesn't really typically work on the timescales and that VCs do. But now what we're seeing, and it's really interesting, is works on energy markets like you guys doing, and heat reuse is super relevant for day to day. So I hope this is going to be interesting. I'm taking the different approach, the impacts of energy on AI rather than AI on energy. And I hope that this brings a different viewpoint. Before we talk about the impacts of energy, this is a slide from Vertiv. Vertiv is a cooling company. It's a liquid cooling company for data centers. They're talking about exponential AI computing power on a rack. So a rack is just a couple of servers together. Typically, a data center has between 500 and 1,000 racks in a data center. And what we see, and this is really interesting, is that in 2024, someone told me that racks are 120 kilowatts. So that's the amount of power needed. And most of that goes out of way as heat. And then someone said, well, it's going to be more. When I asked how much more, no one knew. And now we know it's going to be a megawatt per rack. So then you get to gigawatts, gigafactories of AI, which is incredible. But what's more incredible about this slide specifically is actually the projected industry average, the last bar. And what we could see is that while there are AI initiatives and they are grabbing the headlines, most of the data centers out there in the world are actually non-AI. And AI is pushing the non-AI data centers to have even more energy. So 5 times more energy per rack, which is incredible because every 4 years, a data center removes its servers and puts in new ones. So even on existing data centers, you're going to see 5 times more energy in the coming years, which is going to bring an untold strain on the distribution grid and the transmission grids. And we could kind of see that already happening by and in the backlog, the energy has been for AI from actually this is the IEA report that everyone's been citing. I read it too. It's incredible. This is a backlog of power transformers. So anyone in the DSO industry, which I was trying to used to be in my past, knows that transformers are not the most rarest of commodities. There's going to be, and then suddenly AI comes in, and then you need much more grid. And that backlog of just power transformers is showing how much energy is needed by the data centers and how much this is going to grow. And then companies like Schneider Electric and so on are going to benefit and have a backlog. And we're going to talk about that in a second. But before I do, I wanted to show you this really cool visual from Mitsubishi Heavy Industries. Mitsubishi Heavy Industries is a company, a subsidiary of Mitsubishi that does hyperscale data center infrastructures. They don't do the servers themselves, but they create the whole manifold that would go into a hyperscale. And what we could see on the right, we could see a micro edge, micro DC. So all these would be technically grid connected, and we're going to talk about that in a second. But it would be a grid connected. It would have its own substation, and then it would have its own gas turbines, right? Because in the near future, we're all talking about natural gas. So if you're Google, Amazon, Meta, and Microsoft, you want to offset those emissions. So some of the technologies we're going to see there is point source carbon capture, my VC firm has invested in a company like that. We're going to see liquid actually cooling in the data centers from companies like Zutacore that did two-phase liquid cooling. So a lot of really, really cool things are going on in this map. It's a lot to take in. I don't want to go into every single one. But this is basically how the industry is looking at these gigawatt, gigascale factories in a way. What's really, really, really important, I think, more than anything else, is the amount of capital going into data centers. This is something that should be talked about because A, it's incredible. B, it really can make changes in places where on the energy world that haven't been there previously. So let's just say you're Stargate, you want to put $500 billion into a data center project. A lot of that is going into infrastructure rather than servers. And you're going to build that in Texas. And Texas is one of the most liberal markets in the United States. You have a lot of land. You could do whatever you wanted with it. And what they're going to do with it is going to be really, really interesting because that's going to show where the market is heading in terms of renewable energy technologies, including fusion, including fission, including geothermal. Microsoft is putting $80 billion in 2025. Google's putting $75 billion. These are insane numbers. And there's a lot of opportunity, but there's also a lot of risk in that because these companies are putting on a lot of money. They're expecting to have data centers up and running as fast as possible. And when we're talking about like just like nuclear, Oklo, which is one of the more famous SMRs, is saying they're going to have commercial units by 2029. That's not fast enough. So there's a problem about where the power is going to come from. And what we could see is on the right is that there's a gas turbine backlog due to AI. I heard rumors of in webinars and podcasts of 2031. That's like a backlog until then of just like Siemens and GE just churning out natural gas plants, CCGTs. And the backlog is real. And that goes to show, well, there are going to be data centers that won't have these natural gas power plants. So where are they going to get their energy from? Because they need 24/7 firm power. So there's a question behind the meter, in front of the meter. Google kind of went ahead and said, well, we're only going to buy from an energy supplier. We're not going to have behind the meter generation, maybe as a backup, but we're going to purchase power from the grid and not take care of the operational sides of energy, which is enormous. They don't have the manpower. They don't have the personnel to actually operate these systems as efficiently as possible. So Google's saying everything's going to be grid connected, and they're going to use a system called a clean transition tariff, a CTT, which is not like a real tariff, but basically they're going to their energy provider or DSO, TSO, whatever, and saying we're going to pay a premium for firm clean energy power, and we don't care where it comes from. But they have a lot of say in where they come from because they're paying $50, $60 more per megawatt, $60 more per megawatt hour. But there's also PPAs. Maybe there are other financing models out there currently that might benefit more from a single user that's suddenly using 200 megawatts and needs, or a gigawatt. And just like Microsoft buying power from, I don't even remember the energy provider, which is going to turn back the nuclear site, 800 megawatts. How does that work? What's the best way for the energy market to go forward from there? Those are open questions. I don't think that someone really knows yet what's the best way to do this because the technology just isn't there. Firm power from renewables isn't there yet. So it'd be interesting to see where that goes. And I think that From my perspective, while there are many challenges in data centers, there are really incredible opportunities. One of the biggest problems of being a deep tech investor is the values of death. So there are actually two. One is out of research. Where do I get funding for my research project? Or now that I want it to become a commercial technology, and I've seen this many times over. But then there's us, the venture capitalists in the middle. And then from there, what is bankable? If I need 100 million or 200 million to build my geothermal project, let's call you Fervo Energy, I need a lot of capital. And usually that capital comes from infrastructure funds, but this is a new technology. So what do I do? Where do I go? Google has my back. They need power now, and they're willing to put a lot of money to fill that first commercial operation void. Google, Amazon, Facebook are doing, Meta and Microsoft are doing amazing things in filling the valley of death for new technologies that will be relevant for data centers. That being said, any technology that's not being a data center in the renewable space or in the clean tech energy space is getting less funding now. So it's a double-edged sword. These are a couple of companies we talked about. Fervo is doing enhanced geothermal systems. So it's basically drilling 3 kilometers into the ground and using fracking to create geothermal systems. They raised $500 million, mainly from an offtake agreement with Google. Oklo, which one of its investors is Sam Altman, is a public company with $5 billion. By the way, it's only commercial in 2030. It's already worth $5 billion, and it's only going to be commercial in 2030. And it's fission, not fusion. Fusion is going to be even further in the future. Form Energy, that does iron air batteries, long duration batteries, raised $1.2 billion. X Energy, another small one. A lot of money is going into trying to solve the power problem for data centers because it's real. Where does that leave the research community, the VC community, and the people listening to this webinar? So one of the things that the DOE does lift off reports, which is amazing. They talked about long duration storage, that there aren't any market signals. I think Dimitri talked about this a little. There aren't clear market signals for load falling long duration storage. What do I mean by this? If you talk to an energy trader and ask them to model a battery, it's always going to be lithium ion 4 hours, maybe 2 hours. No one knows how to model 10 to 100 in real time, not in forecast, in commercial settings. So that's going to be a challenge that no one really knows how to grasp. And then suddenly there's a physical problem and people are willing to pay to solve that physical problem, a lot of money. And so can long duration storage benefit from the AI wave? I say yes. Seasonal storage. No one knows how to price seasonal storage yet. That could be solved as well. Is there any new structure apart from PPAs, CTTs, maybe something else? I think Dimitri talked about flexibility. That's an interesting topic. I think most data centers are saying, oh, this is my firm power. I don't want to touch it. Maybe there are better incentives to making these data centers look at and say, oh, I'm not using all my power right now. I'm going to use less. I'm going to try to optimize myself either by liquid cooling and heat management and heat optimization. What can governments do when someone says, oh, wait, I want to build 200 megawatts in the middle of nowhere? What can it do? So heat reuse is definitely one of the things that a lot of companies are looking at, and a lot of governments are looking at, I know. But what if we take a New York City skyscraper model? In New York City, when you build above a certain floor, you commit to the city that you are building public lands as well. So these could be public parks in the middle of the skyscraper. It's a floor. You're committing money to the city if you're going to build above something, above a certain line. Can we do that with data centers? Can we make data centers pay for grid updates that they're not actually using? because they're using so much, can there be extra tariffs? That could create a just energy transition, that could create stronger grids that everyone needs. And there are a bunch of problems here as well. But I think that that's a new interesting model that might work. I don't know. And lastly, can AI save itself? A lot of people talked up here about different ways AI can be utilized for the energy transition. And so I'm like, there are a bunch of things, new materials, more efficient buildings for sure. A lot of the startups you're looking at today are talking about AI usages in their buildings, hyperlocal flexibility. I saw that Iron Mountain, one of the biggest data center providers in the world, has signed up with a startup that actually aggregates solar panels from rooftops. So when you're talking about the social impact of new renewables, maybe we can aggregate the distribution side and power a 50 megawatt system where with an incredible feed-in tariff price that customers otherwise couldn't have had, because money is less an issue with data centers. And for sure, more efficient grids, digital twins, ADMS, and DLRs, all of those are using AI to make a more efficient grid. If we can lower the voltages at the distribution grid by 5%, that's an amazing achievement. And usually they're over voltaged at the last end. They're, instead of 240, they're going to be 250, 260, because the last person on the load has the least power quality or the worst power quality. Never mind. And what about more efficient interconnections? How do we know what we want to add to the grid? That's a challenge that DSOs and TSOs are facing. And right now it's just it's a dumb queue. What if we can make it smart? What if we could prioritize geographically, make heat maps? Those type of things AI can really, really help with. Thank you everyone for your time. Feel free to contact me at this email with any questions.
Okay, Nadav, thank you very much for the presentation and certainly for bringing a new angle into the whole discussion of AI and energy. And of course, you focused on the infrastructure and the different applications, which is very important because at the end, yes, how to find money and to use this to build all this is, the critical factor. We may discuss energy unpredictability, energy demand unpredictability as the critical factor, but in many issues in the practical life, the critical factor is to find the money.
Yes, for sure.
Now, you mentioned very aptly the geothermal thermal energy. I have to point out that Israel is a pioneer in developing geothermal applications, and you have one or two companies who have been working worldwide over the last 30, 40 years. So it was not accidental that you brought up the issue of geothermal energy. And because geothermal energy is the big unknown and underrated, because it's 365, 24 hours a day green energy. Yes, geothermal energy is highly relevant, I think, because it could actually make the difference in the energy supply gap, which inevitably is going to appear at one point. If we look at the way things go. So technology, very much as you mentioned, and the valley of death moment are yes, critical factors. So can I ask if there are any questions on Nadav's presentation to be answered now, and then we have some minutes to have a general discussion? No, I will say that all presentations will be included in a video. I mean, we have a video of the webinar, which is going to be posted in the next few days. And before that, hopefully, all participants will have sent me their presentations, which we can load tomorrow on the microsite, so everybody can see these very, very interesting presentations. But in addition, we're going also to have a video of the whole webinar, and this will be posted. I don't think it will be posted tomorrow or the day after, but maybe by the end of the week it will have been posted, and we are going to send you a message where you can see it and all that. So the floor is open to questions for all the presentations and the whole subject. And but I see no hands. I see one hand. Hold on a minute. One hand here. Where is it? Here. I have an observation here from Christos Kolovos, who also posed an earlier question. He says, I have just asked the same question to 3 different AI machines. How much energy is annually consumed for cryptocurrency production? I got 3 different answers. So what about the credibility of AI machines, and how can we trust AI to predict energy growth? Very interesting question. So whoever wants to provide an answer or a response would be much appreciated. Dimitra.
Can I reply?
Dimitra,
George, you want to go?
Then Mr. Yes, Dimitra.
Thank you, Steve. So actually, I had the same question. If you ask some ChatGPT or whatever, like how many vowels are in my last name, Apostolopoulou, and it's gonna say like I don't know 2, and then you correct it. No, there are like how many do I have? I don't know. Let's say 6. It doesn't really like learn from correcting the mistakes. So lately there has been the rise of interpretable AI, which I think is going to help a lot in special powers operations, because as you mentioned, we need to have the lights on. Okay, the main goal of power systems is to have the lights on. Okay, we need to do it in a cost-efficient, sustainable, and resilient way, but the main thing is to balance supply and demand. So by having interpretable AI, you don't just have a black box and you have the result. You have some features that explain to you why the decision was that, and then you can provide input back to the AI tool to modify. They're like, I don't think this is related to that. But trusting AI we do have a long way to go on that. Second is about liability. There's a political cost having a blackout or having people not being able to have electricity. So who is liable for that? Is it the company, the distribution company, the operator, the software company? So these are things that need to be determined by AI governors, which is another, I think, big issue in trusting AI and using it.
Okay, thank you. Professor Atsalakis, I know you have to go, right? Because you have another obligation.
Yes, just I want to add something that the forecasting models for electricity demand, it depends more than the reliable data that we'll have. And the models are much more reliable than when you ask the ChatGPT. Something that is not very clear. So sure, there will be models, just the data will be changed so fast that we have to adapt all time the models.
Okay, that brings us to the initial observation by Professor Veskoukis about the quality of data. And we need to, as we ride the AI bandwagon, we need to be careful on what data we use and the type of data. Okay.
Yes.
So you agree on that? Okay, thank you very much. We can release you now. You have to go to an
Okay, thank you very
interview.
much.
Okay,
Bye-bye to all.
okay. So, any other questions? Let me see the box here.
Stacey, if you don't mind, I have raised
Yes,
my hand.
okay, Vasilis, you have the floor. Yes.
Well, I'd like to comment on that as well. I need to remind you of the first days of search engines. We were so excited that we had a way to find out what's out there. Sooner or later, we realized that the revenue model these companies use make them very, very, very biased. If you go ahead and pay in Google or whomever, then you have your result displayed first on relevant searches. And the more you pay, the higher rank you get. So it's as a matter of revenue model, the search engines agreed. Actually, they made it a part of the game, and we all think it's okay to do that, to tune and bias the results according to other factors, not the results themselves, the content. Imagine what is going to happen if the same thing goes ahead with AI as well. It will not be like a link or a commercial posting or whatever. It will be like some sort of intelligence, and I emphasize the sort of intelligence. I think intelligence is highly exaggerated here, that is giving me biased results to serve some sort of an agenda, which I don't know. And in this case, in the case of AI, we will not. It will not be as clearly visible as it is in the case of search engines. If you combine this with the shift of culture regarding data, let us think about how it was like 10 years ago, or maybe a little bit more. There was a developing culture of open data, and everything was supposed to be open, and many legislations have been aligned according to this to this principle. But the more we realize that data is power, then the culture of open data is severely threatened. The thing is that those who have access to data, even if it's not personal data or if it cannot be in any way characterized as such, they save the data for themselves. Because why? Because they are able to let's say train their own models of AI and do stuff that it gives them some sort of advantage. So we need to develop a culture, and this is very important that we get sensitive and we get aware of this factor before trying to put some really heavy load on mission critical applications. We all need AI. AI definitely, in the end, it will solve many more problems than it would create. I'm mentioning the energy demand issue, but this will not come automatically. It will not come on its own. We need to develop cultures, and we need to develop awareness, and everything else will find its way.
Yes. Very timely, this observation, and the parallelism with search engines is very prescient, in the sense that, yes, I mean, there could be questions and situations where the AI systems would probably be trained to respond to whoever has a subscription or not a subscription. Okay, so if we use professionally AI, you will know that you have different types of subscription, and this affects the speed and quality of your search and the response. So yes, there are parallels. Now, to what extent this will be fully I mean, fully mirrored. I don't know, but the cost, the issue of cost and payment as you go, and revenue generated from AI sooner rather than later, I think, will arise. Any other observations on that issue or any other issue? I do not see any hands. I think we're tired. We had 2 very intense hours discussing this topic. I think we will draw a line in the sense that we have to capitalize on these very interesting presentations and conversations we had. Will help in this process, and we'll be with you very shortly with the organized content of this webinar, and also we'll chart our thinking forward to do other things, including, first of all, the presentation of the IEA report on AI, which hopefully will be sometime in the first half of June. But we'll let you know well in advance on that. So thank you all once again for your wholehearted response in our invitation and your participation today, which I can see was very enthusiastic. Okay, so good afternoon from Athens to Oxford, to Tel Aviv, to Hanya, and to Athens, and to UAE, Abu Dhabi, I'm not sure, to Alex Papaspiridis. Okay, so goodbye from me and from all our friends here.
Thank you very much.
Thank you.